Okay, so picking up from the last video, let's take a look now at how to compute a t-test with SPSS. So I assume that you've been able to get into a Porto. I'll assume that SPSS started. If for some reason it hasn't, we'll double-click the SPSS icon here. And let's bring the data into SPSS. Again, it's already up in a Porto. So I'm going to click Open Data. Again, that same sample file. You'll be working with the file specified in the lab. But let's open that up. And the first thing that I want to do is a one-sample t-test. Let's imagine that this test, whatever this test was, has an expected score of 69. Let's assume that 69 is the expected score on this for the population. I have males and females here. One group of them is called Group 1, the other is called Group 2. And I want to combine these groups now and just look to see whether or not the average score here is different than the expected value of 69. So I'm going to go up to Analyze now and compare means and proportions. And again, I'm doing a one-sample t-test. So I'll click one-sample t-test. And we're interested in testing the variable score and seeing whether that is different from our test value, whether the mean for our score is in our data set is equivalent to, is significantly different, statistically significantly different than our test value of 69. Make sure that Estimate Effect Sizes is checked and click OK. And SPSS will generate for us a one-sample t-test. Let's take a look at how to read this. The first table reports some descriptive statistics about our data. We have sample size, mean, and standard deviation. The second table shows the results of the t-test. Here's the mean difference between our sample mean and the test value of 69. Okay, had you computed the t-value manually, it would have come out to this -2. Given that there are 100 cases in the data file, the degrees of freedom for the test is 99. And look now at the statistical significance of the difference between the sample mean and the test value. As we discussed in class, we normally reject a null hypothesis when the probability of getting a particular t-score is less than 0.05. In this case, the t-score is -2, and as SPSS shows, the probability of such a t-score is less than 0.05, so we would reject our null hypothesis. Okay, finally, we have the effect size in this third table. We're interested in the point value estimate of Cohen's d, which is -0.2. Recalling our rule of thumb, a value of -0.2 and value of positive 0.2 also suggests that the treatment had only a very weak effect on scores. So there you have it. That's a one-sample t-test. Let's take a look now at what would happen if we compared scores for males and scores for females. So to do that, again, I'm going to go up to Analyze. Again, compare means and proportions. But this time we want an independent sample t-test. We have men versus women. So again, our test variable is score. Our grouping variable, in other words, we'll be comparing across gender. So we're going to click gender and send that to our grouping variable area. And now we have to define our groups. So to do that, I'm going to type in male and I'm going to type in female. Now, it's really important here to remember that you have to type these group names exactly as they appear in the data file. If you were to type capital M-A-L-E, capital F-E-M-A-L-E, SPS would throw an error. So it has to be exactly what appears in the data file, and it has to be case sensitive. It's case sensitive. So we'll click OK here, or click Continue, I should say. And again, we'll keep estimate effect sizes checked. We'll click OK. And there's our t-test. And it looks as if the mean for the men was 61.32. The mean for the females was 71.68. I think if you go back and check from the previous video, you'll see the same values for the means and for the standard deviations. Our sample size was 50 plus 50, or 100, and our degrees of freedom, therefore, is always in an independent samples t-test n minus 2, so 100 minus 2 is 98. Had you computed these t-values manually, you would have gotten negative 4.536, and it looks as if for both a one-tailed and two-tailed t-test, this t-score of negative 4.536 is statistically significant, because the probability of getting a t-value, of computing a t-value of this level, of this magnitude, is very small. It's less than 0.001 probability. So we have here a statistically significant relationship. Let's take a look now at the effect size. And it looks like there is a pretty large effect when we compare the men and the women. Recall that for our previous one sample t-test, we had only a negligible effect. We had some effect, but it was very small. Here we have an effect negative 0.907. So that's a pretty large effect. All right, that's pretty much it. A lot easier than computing these t-statistics, I think, by hand. The only thing that I'd ask you to remember is that when you report these, when you report the findings from SPSS, please do not simply copy these tables into your lab report, but create something that looks like the example that I've given you in the lab instructions. Okay,